So that means vector A plus vector B is equal to A1 plus A2 comma B1 plus B2. So that means when you add the two vectors in the component form, you can add the coordinates component-wise. So you have the vector A1, B1 plus vector A2, B2. Then you may first add the x coordinates A1 and then A2. Then you add the two y coordinates B1 plus B2 to get the sum of these two vectors. And similarly, when we multiply a vector in component form by a scalar k times a, you may just multiply each component by this number k. And also for the subtraction, you have the a minus b, then this is equal to a1 minus a2 and b1 minus b2. Now let's look at a new concept, dot product. So if we have the two vectors a and b, then the dot product of a and b is defined as a1 times a2 plus b1 times b2. So right now you see this dot product is a real number, right? Not a vector anymore. So the dot product of two vectors is a real number. And when we define this dot product, you can switch the position of a and b. Actually, b dot product a, you also get the same result. Now let's look at one problem. It's on the page 611, problem 39. And we know the R, S, and T, then perform the operation indicated, then write the vector answers in the form, okay, in this component form. So this is page 611, problem 39. We first know the three vectors are and then vector t, and we need to find 2r plus 3t. Okay, this vector, this operation only involves the two vectors. We don't need the third vector. So this is equal to 2 times vector 3 negative 2 and 3 plus 3 times vector 4 negative 6. So let's first do the scalar multiplication. So this is equal to 6 and negative 4. And this is equal to 12 and negative 18. Then we add these two vectors. We have the 6 plus 12, 18, negative 4 plus negative 18. Then you get negative 22. Now, suppose we want to find the dot product of the S and T. Vector S is equal to negative 1, 5. Then the dot product of the S and T the same as the T dot S, so it's equal to negative 1, the fourth component times the fourth component of this T, that is the 4. Then the second component of this S, 5, times the second component of this T, that is the negative 6. Then you simplify, you have the negative 4 minus 30, then you get negative 34. So this is the dot product. Now, let's talk about the angle between two vectors, and this is a new concept. And suppose we have the vector A and then vector B and let's draw them in the rectangular plane. So this is my vector A, and this is the vector B. Now, the angle between this vector A and vector B is theta. So, we know this one begin with the terminal point of the vector B and terminates at the terminal point of the vector A is just the vector A minus vector B. Okay, so let's get the A minus B, and which is equal to A1 minus A2 and B1 minus B2. Now, let's get the magnitude of the A minus B. So this is equal to the square root of A1 minus A2 square plus B1 minus B2 square. And also let's get the magnitude of A and B. So the magnitude of A is equal to A1 square root of A1 square plus B1 square. The magnitude of vector B is equal to the square root of A2 square plus B2 square.